spanning the globe to bring you the constant variety of jank, the thrill of victory, and the agony of defeat. The human drama of electronics repair. This is the Big Bad Bench Wide World of Jank.
Thank you to all my patrons. Hello everyone, Happy New Year. My name is John, aka Big Bad Biologist, and we are here at the Big Bad Bench. I don't know how to do intros or X out, but hi. So right here you can see we have an Apple system doing stuff. It's doing some diagnostic, and we're going to be working on an Apple system. Does that mean that I've already fixed it even before the stream started? No, it does not. This is just showing you that we have an Apple IIc system set up. So let's, oh no, that is not the right thing. Here we go. So here's the Apple IIc that I cosmetically restored. It really didn't need anything functionally. We are currently booted into Apple diagnostic software through the smart port to SD-V2 from KCOBA, and we are outputting through the A2C DVI V2.0 from Mr. Tech Gadget, and it works great. And so if we look here, it's just beautiful, nice and sharp when you're doing this one. It's just such a nice setup. I'm gonna do a bad thing and shut this off in the middle, just to show that we have other ways of connecting up. So here's the A2C DVI V2.0, and this one I had to do this little mod on there to get it to work with my TV, but it's super easy mod. So that's with HDMI. We can also go and connect with composite. Bloop. And let's switch our TV over to composite. Now we're doing the same booting thing. So, oh, no, not that. What the heck, man? I think I was up too late. I think it was up to like 9:30 last night. That is way too late for me. But you can see this looks okay. It's nowhere near as sharp as the HDMI thing. So this is just to prove that I have a good Apple IIc setup. And let's shut this off and let's bring the mess in that we're going to be working on today. Because we are working on an Apple IIc clone system. And switch this out real quick with this one. And hello. Alright, so you can see it's already apart, and I mean, if this is the floppy drive to it, so you kind of knew I had it sort of apart already. So this Laser 128EX2 came from Javier, who someone sent it to him. I remember him saying that it was in a flood, but I just watched his videos this morning, and apparently this was actually in Katrina. So this is like a big flood. Katrina was kind of a wild situation. So this is what we're going to be working on. So take a look at this beauty real quick while I say hi to folks in the chat. We got Dave's Vintage Apple Tech. We got All Things DG. We got Ian Scott and Francois Reval and Gut Bomb and Socket Winch and Trina's Technobabble. Hello. Yeah, so it's a vintage flood at this point. That's a good point. So it's a neat looking machine, and actually I guess we may as well grab the 2C. You can see by scale, it's maybe a quarter, 25% bigger than the Apple IIc. Functionally, it's very similar. It's more similar to Apple IIc Plus, I guess. But yeah, so this is how Javier sent it to me. This floppy drive was flopping around inside there, and I thought that was not a good thing to do, so I took it out. Let's zoom in a little bit here. It's Garth Beagle. Hello, Garth Beagle. All right. Oh, side note, if you happen to have an Apple IIc and you need a mouse, this microspeed guy for the the Mac Plus works great on the Apple IIc. Okay, so this is the inside of this beast. Should we turn it? Should we turn it this way? It's a better clone than the original. Well, that's sort of debatable. I don't know. I'm not. I have some Apple IIs. Why are we doing this? Okay, here we go. Let's do that. There's hot glue everywhere, and I think this was Javier. He took all of the EMI shielding out so that it was cheaper to transport, I guess. And I think he hot glued the floppy drive and keyboard and such, because there's hot glue over all this, and I don't think this particular hot glue came from VTech. There was hot glue from VTech that we'll get to, but this one was Javier, I think. Not the best. I would highly advise against hot gluing stuff together and then shipping it that way. It's just like I heard rattling, and it's just like all these little hot glue bits that were inside the case. But anyway, this is this guy. You can see it's a relatively simple setup. We have one of the big things about the EX2 is that it has this memory board, this memory expansion board populated, so this should be a 1 meg expansion, and I think those are 41256 chips on there, so that should be pretty easy. The other thing about this is that there was a real-time clock, there was a battery here, so I think Javier got rid of that battery. There's a bunch of corrosion, so one of the things we're going to do first is take this out. Don't know how to take this out. It's kind of interesting. Oh, I guess we got to take the volume knob off there. Did I miss someone coming? So, take off that volume knob. Yeah, and then that comes up. Alright, that's good. He did a lot of cleaning already. I went back in his original video, and this was really bad, and it was very yellow. There's some hot glue that was hiding down there. Set you aside for a minute. And let's take a look at things. I guess what we should, well, yeah, so that's the real-time clock board, and I think when things look this bad, we're not even going to power it up. Hello, Jean-Francois. Who else did I miss? Apple IIgs is the best Apple II ever. Got bombs gonna throw down. Oh, hello, Brad Bell. And Justin D. Morgan, hello. So yeah, I think the first thing we're going to do is we're going to take this guy off. I did also watch Adrian's video about this computer, or at least the EX, not necessarily the EX2. And his does not have this board, and so I think we can just get rid of this guy. Oh, it seems to be very well adhered, so yeah, that's not good. Hello, Power Vintage. Power Vintage has released a couple videos this week. He's working overtime. Okay, so these, oh, so that one whatever screw was holding that in no longer exists. We have, look at that. Yeah, that's not a thing you see every day. It looks like a clam. It's a little capacitor split. That's neat. Yeah, we're definitely not powering that on with that on there. So here, oh, here's more of the hot glue from Javier. Here's the original hot glue. So this is one of the annoying things that VTech did, was they didn't put sockets for these cables. They just soldered the cables in and then hot glued them. So that's fun. Same thing with the keyboard cable down here. Assuming that all of these things are from Javier, we can get rid of that. Okay, let's take off the memory expansion board. What's underneath here? Oh God. So apparently the ROM is on the bottom. Okay. What does this little switch do? We got a switch. What's that? Hello, Chris Jackson. Yeah, I thought the ROM was up here. Why is the ROM on the bottom? What? I could have... Oh, there's a door on the bottom for the ROM. Right, okay. Yep, I do remember seeing that. Okay. Alrighty. Let's take that off. So I don't know why Javier decided to send this to me. He must have gone on to Dave's stream and was like, hey, I have this broken laser 128. And Garth probably said, oh, send it to John. He'll work on anything. So, I mean, this looks actually really nice. Garth says it's not my fault. Okay, Garth, whatever. Okay. So let's take a look under the microscope. Let's get a little bit closer view of this guy and see if Javier spun the wheel of jank. That's excellent. Oh, Trina is counteracting your story there, Garth. Let's go in the microscope. Let's see what we're looking at here. So we got some logic chips. They look pretty nice. Got this. I think that's the keyboard controller. And there's our processor, the 65CO2. One of the neat things about this machine is it can run at different speeds. I think it's like 1, 2, and 4 megahertz. The RAM chips look okay, albeit a little bit crusty. Just looking for like major... Ooh, what is that? That is some sort of a jumper. That is jumping something. It looks like there was an alternate possibility there between that and that. Okay. Hello, Pat Brennan. Yeah, everyone else will send it back. Everyone else is smart enough to say no to this stuff. So these are like combined logic chips. Here's a little SRAM. What do we got? Got a little bit of wonky traces, but that's not too bad. This is like a video RAM kind of cache almost, or buffer. That doesn't look good. Probably don't want those two legs touching. That could have happened. and shipping. That's just a whole bunch of inductors and oof. Got some broken ferrite bead there. Look at that. That is a bodge. Okay. There's... Oh, yeah, so there's some definite corrosion under the solder mask here. That's not good. You can see that there's corrosion here on this trace. And that trace, and that trace. Okay, so everyone remember this area. We're kind of near one of the ports. I don't know which port this is. Which port is that? Hold on here. That is near modem port 2. Okay. So yeah, look at all that. Oof, look at you. Oh, we got a 244, that's socketed. That's nice. I like when we see socketed chips. Oh, I don't like when I see corrosion down. Oh, no. I don't like seeing corrosion down in there. Ah, that's not good. These guys, look at that. Stuff hiding under there. Trace, trace, trace. Trace. I need a scrapey majig. That's good. Well, at least these traces are nice and big. But I want to at least mark these to remind myself to come back and look in more detail. I have no idea where any of these go. Okay, well that's something. It's an area of potential interest later on. So what do you think the first things we should do? So if we don't see anything super awful, we're going to power this up because I have a feeling Javier already powered it up. So we're not going to do anything worse than what's already happened. That's not a good thing. That looks like it used to be a trace. Maybe not. Yeah. But all these little spots, they're gonna have to be gone over and clear a solder mask off, clear out the corrosion, and then I mean, I don't normally put solder mask back on things, but I do coat them with solder just to make sure that they're not going to corrode any further. Alright, while we're looking at this, let's beat this out and see what we got. Hey, Adam Baranek. Hello, Charles Bullock. Hello, Doro. Hello, Sweet Comparing. Happy New Year, y'all. Alright, what do we got here? We got a thing that goes there to there. Yep. And a thing that goes there to there. Alright, that's good. I can't tell if that's supposed to be a trace or not. I think it is. Yeah, I think there's a trace that comes around here and goes over that. Where do you go, you trace? Come on. Well, let's see. Do we go at least from here? Yeah, I think that's hosed. I think that trace is gone. Okay. That's one that's over near the expansion port. Hey, it's felt temp reparatio. Happy New Year. Alright, so that's something. We got some voltage regulators here. So that's definitely one of the first things we should check. Once we apply some electromagneticity to this. I think what I'm gonna do, let's go back to here real quick. Let's pull out the RAM chips. These should be 41464 RAM chips. Let's stick these in this thing. What's this called? The Retro Chip Tester Pro. While we're looking at stuff, we can be testing RAM. We're like multitasking. I can barely do one task at a time, but let's see. Oh, y'all can't see that. Y'all definitely can't see that. Oh god. No, I did it wrong. Alright. Go back here. We want DRAMs common. Okay. And then I think if we go back 4464. Okay, good. That's testing away. Hey, it's Jason Starbuck. Hello, Happy New Year. Alright, let's pop those other RAM chips out while we're here. That thing's testing good. It's got some scarfy looking legs, but it's testing okay. So we should be able to power this up without the big RAM expansion board. I think it'll work fine without that. But we need some regular RAM, and I guess we should pop out the video RAM. That should be the same exact stuff. In the video description, I have the technical hardware manual or whatever it's called for this thing. If you're interested in reading more, I've only looked at a few things in it so far, but one of the first things I did was try to figure out what kind of RAM was in this beast. Okay. All right. Let's go back to the microscope. Look in those sockets since we got this pulled off. Yeah, they're fine. No corrosion over here. Let's look at the back. The back is theoretically... Oh, stuff fell off. I think it was just a blob of... oh, jeez. I already saw a bad thing. Alright. That chip works. That's a good chip. Put another chip in real quick. Let's look around here. Hey, Carthor. Still a little dirty. Still a little dirty. Some of that Louisiana mud. Mississippi. Some nice bodge wires. Everyone loves bodge wires. Yeah, I think Javier already cleaned it once with vinegar. At least that's what he said he was going to do, I think, in one of the videos. So this has been cleaned somewhat. It's definitely cleaner than it was when he first looked at it. A little bit of gunk. A little gunk. Nothing too bad. This side of the board looks better than the other side. Ram chip 2 is good. Alright, nice. So we know we got some good parts here. That's always useful. Okay, a little more yellow. This, I don't know what that is. This doesn't look quite set right. Nice to know that it's a standard 27C 256. In case we need to make a new one. Hello, other Starbuck. Oh, okay. So this was the part on the top where things were ugly. And surprise, they're ugly on the bottom too. Wow. Mississippi mud. Yeah. I think most of these traces are so big that it's probably fine. Alright, RAM chip 3 is good. Are we gonna have all functioning RAM chips? How nice would that be? Speaking of functioning RAM chips, last weekend I did that stream about the 286, and let's start on this side. Good. It was very buggy, and so I basically took that machine apart and started testing all of its RAM. I did find some bad RAM chips, but I also found 4 traces that I missed repairing the first time I repaired that 286. So once that's up, it's all good now. That's a happy computer now. There we go. There's some crust, but all these traces are still tracing. That's good. That's good. Oh. Oh, no. That one's good. Alright. Cool beans. This one goes somewhere over there. Okay. Next RAM chip. Yeah, it's hard to see. Oh, this is sharp RAM. most of the markings have been removed. Alright, so this spot's kind of nasty. I'm probably gonna use my Dremel to polish up some of this solder mask and get that off of there so that this corrosion's not hanging out underneath all those traces. Okay. Yeah, some more over here. Okay. Alright, so there's nothing super disgusting. That's good. I mean, it's not great, but it's not the most awful thing that we've ever seen here. Yeah, let's see if I can... Oh, there's little bits flying off of that board. Okay, that... got one more RAM chip to test. Let's deoxide these real quick. Soak them up. Soak it. That one's good too. All this RAM is good RAM. I even went through my stocks and found some 41464s this morning in case we needed them. Okay. So where's... This goes this way. Yeah, the mouse nest in the Commodore was pretty awful. That was probably the worst. Oh, here, let's see. Can kind of see it there. Legs on that thing are not great, so I'm gonna grab my Dremel now, and let's do a little bit of polishing on that chip since I don't like how it looks. Come on. So this one's my diamond bit that I use for stuff, but these are the polishing bits that I like to use for cleaning up traces and chips and stuff like that. Alright, so all 4 of those RAM chips passed. That's excellent. That is a really good start. That should be somewhat better. And I don't think that the computer always uses this. I think it's only in certain situations that it uses this part of the video memory. I don't think there's anything actually living on this board anymore. I imagine that it probably had some like crawdads at some point. Alright, so should we apply some juice to this thing? I don't exactly know which one of these is which, but we can probably figure it out. It's probably going to have 5 volts, 12 volts, and a negative something or other. Let's make sure the switch is good. Alright, full send. Let's make sure our switch is good. Really? Oh, you can't see. Let me zoom out a little bit. We're in beat mode. Oh, there it is. Okay. Switch is good. Okay, so that way we're now off. I'm going to use my Apple II power supply for this. Apple IIc power. Ooh, that was crusty. Crusty. I'm going to use all my deoxit on this job. Okay. Let's plug in. Let's do our composite first. And let's make sure our TV's on. Should have a speaker around here. It's probably not the right speaker, but it's a speaker. Where's the speaker header? Oh, down here. Justin is grabbing his fire extinguisher. All right, here we go. 3, 2, 1. Okay. I see no signs of life whatsoever. So let's check some voltage. Just putting my fingers on things to see if there's like major heat anywhere. Don't feel much of anything. So there we got our 14 in. That's probably, oh, we got 12, 14, 14, 5, 14. Negative 12, negative 20, negative 12. So it looks like we're generating all of the voltages that we need to do. Yeah, no smoke that's a really good thing. Let's try the other video port real quick. Let's try the other one. Supposedly that this will work with this, but it might only be in black and white, which is totally fine with me as long as we have something. All right, so which one? This one is our video port. And go here. This. Boop, boop, boop. All right. This might give us a signal regardless because there's like a thing. Wow. Yeah, not. Oh. Oh, look at this. Look at this. Holy crap. Oh no, okay, that's the Apple IIc DVI. That's not the computer actually doing a thing. All right, never mind. Yeah, no, that's not a real thing. That fooled me for a second. That's like, hey, is your computer actually working? All right, let's go. Let's go to. All right, so if we go to here, let's see what our pins should be. Ba, 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 ba. All right. So let's look for clocks. Why don't we look for clocks? So I think pin 37, this Phi 2, is our clock. Let's look for a clock. Oh. No, we're not going to be able to see everything. We're only... I don't know about the port being 15 kilohertz. This TV does not do 15 kilohertz, so I mean the Apple IIc DVI might be doing funky stuff and converting it. Alrighty, let's go on to a ground. Let's assume so. Yeah, that goes around to the other side. Alrighty. So let's... Are we on or not? Yeah, I guess we're on. Yeah, okay, so that's on. One. That was high. 2, 3. Is that pin 37? Oh no. 4. We need to go to 4. Let's go to auto. Okay. So that's pin 37. And that is no clock signal. Okay. Well, that's telling us a thing. Let's go to a real oscillator. Oh, that's a nice one. Can you see what I see? No, you can't see what I see. Oh my God, Rygal, you are the worst. What system is that for HDMI output? This is only for Apple IIc systems. There we go. Now you can kind of see. And this is like 3.7. Yeah, that's what that's supposed to be. Okay, so that's a good thing. It's called the A2C DVI. I think the newer version even has something audio support. Okay, so somewhere over here, I think this guy is being used to generate clock signals. And again, let's go back to there. Yeah, there ain't nothing on there. Let's go to this guy. This is the 14 kilohertz oscillator. Or no, 14 megahertz. Okay. So that one's working too. So that's good. Alright, so somewhere on the back of that guy should be making some kind of clock. But without a clock, we're not going to get a whole lot of anything happening. Okay. Well, that's fun. All right, let's see if we can find it on the instructions, the technical reference. So basically what they do is they take the Pi Pico chip and just make a whole board for it, so it doesn't have a whole Pi on it. Let's see here. We gotta go all the way down to the bottom, and then there should be, yeah, here we go. Where's our CPU on this mess? That kind of looks like a CPU. U20? Nope. Oh, I was on the wrong chip. Oh my gosh, I was looking at the wrong chip. Justin, you should have caught that. Let's go back. Let's go back to here. Okay. I was checking the keyboard controller. 1, 2, 3, 4. All right, we still got nothing. Different chip, same result. I don't think there's actually any clock going here. Let's try this again. Oh yeah. Yeah, sorry, Justin. So that's not a clock. That's noise. This is a clock. Okay. All right. So where is our clock generated? Let's go back to this guy. U20, yeah, U20. So that should be pin 37. This guy. Oh. Well, that's interesting. So is that not our clock? So we have these guys. Yeah, they are very cool. Very cool device that you can get HDMI out. I mean, you're not driving many pixels when we're talking about a Apple IIc, so it theoretically is powerful enough. Let's see. What? Yeah, we're talking U20. This is saying, oh. Alright, MPU P0. That's the signal we're looking for on page 1. Okay, it looked like that was tied together. Sorry about that. Hey, Jamie's Hack Shack. Alright, so we gotta find MPU P0 on page 1 of the schematic. This is page 1 of the schematic. Alright, so where is our MPU P0? Where are you hiding? Mouse butt. Oh, here's one. Here's a crystal. Alright, what are you? R136. Can we find R136? R134. That's interesting. See R132, R134. Oh, there's 136. Alright, that one's not the one we want though. That one's not doing much of anything. Okay. One set sees MPU P0. Scream out. Oh, here it is. Okay. Alright, so it looks like it is currently 64-ish degrees in the big bed, at the big bed bench. Okay, so it looks like MPU P0 is generated by U6. Okay, where is U6? Okay. Alright. So if we go back, let me show you this. This is U6 here. Does look like there's some nasty stuff going to it. So that chip might be so somewhere on this chip let's see, what pin was it? Pin 34. So based off of that, should be okay. So they have it like this. Pin 34. Should be 1, 2, 3, 4. 1 and 2 are tied together. So that's something. Okay, yeah, that's correct. Alright, so there's no clock coming out of there. That's one. That's number 4. Oh, you can't see my oscilloscope. Oh, come on. Oscilloscope. Here we go. Alright, again, here's a clock that's doing a thing. Look at how happy he is. Sort of. A little wiggly. My silly scoop. 1, 2, 3, 4. Yeah. That should be the clock going to the CPU. So that's not nothing. Ain't nothing happening there. So what's on this guy? What's making the clock go into that guy? So we're looking at this guy. Oh, not that one. Oh God, I lost it. Now we'll never find it. We'll never find it. Okay, here we go. What do we have for clocks going into here? I can't tell what the heck that says, but that kind of looks like a clock. Oh, S7M, S14M. There we go. Those are probably things we need. I don't know if they're generated by this or if they are part of it. So let's try all of those pins. Let's try those pins. Well, I guess we could also make sure that we're actually getting voltage to that chip. So let's see. There's grounds. Alright, so I think we gotta look at all these. Of course it's smack dab in the middle. Alright, we're gonna have to go under the microscope for this. So that I don't poke at the thing wrong. You only want to poke at things right. Let's go in the microscope. So 1, 2, 3, is that something CLK? Hey, it's Cat. Alright, let's go. Where's the microscope? Microscope. Alright, here's the thing. We're on this chip. And 1, 2. Oh, we can't see anything. That one shouldn't be anything. That one is that something, maybe a clock but it's not showing anything. Then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, 13 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is supposed to be some manner of clock. This is the S14M. And it's just kind of noisy. And then we should have BSS. And then we should have S7M. And we got nothing. Okay. So we got no clocks going to this thing. There's one here called lip sync. That's 1, 2, 3, 4, 5, 6. 5, 6, 7. Yep. Okay. Well, that's fun. All right. So the S 14M L1M the $1 million ball will drop on July 3. I don't think I'll be getting any $1 million balls, that's for sure. Let's see, we gotta go to pin 16 on this side. What happens over here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And there's no activity on that one either. Okay, well that's fun. We are currently missing clocks. We do have some dodgy sort of traces. But let's look at that. Let's look at the schematic again real quick. Nope, not that. This. All right, so up here, S14M, S7M. Page 2 and 4. This is page 2. Weird machines. Oh, you weird machines. What? This is 2. Okay. So now we're on U38. U38 is another one of them fancy dealies that they created. That also has the S7M and the S14M. So do we think that there's a chance that it's over there on that one? I doubt it. But let's try U38. Just for poops and giggles. So let's go back to the microscope. And so it looks very similar, but it's a very different chip. So there's U38 you can see, and we need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 from up here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. That almost looks like a signal. If we go back to here, let's go give you my, oops, I slipped off. There we go. Go back to the oscilloscope, show you what that looks like. It's a wiggle. That's way more than we were getting before. Still not good. It's not a clock signal. So yeah, that's not fun. Okay. Nice. Alright, so I think let's go to page 4 of the schematic. Yeah, no, it wasn't a good clock signal, but it was a wiggle. It was something. Alright, so somewhere on page 4, I think it said, 3. Oh no, this is just showing the connectors. Okay. Oh, so that's saying it's probably going to the side expansion port. Alright, so I think what I'm going to have to do is read the technical manual in much more detail and figure out how the clock is generated, because we are not getting clocks going anywhere. And if we don't have clocks going places, we're just not going to have anything. So I want to see. Oh, I can't even see. So one of the things they have here is this, with a little showing you what's where. Oh, that's a very different board. And that's a very different board. Oh, that's great. Okay. So that sucks. That's not the right board here. Oh, have I been looking at the wrong one? Oh my god. Yeah, so the actual crystals I looked at, and we have stuff coming out of the crystals. The crystals look happy. It's other stuff that's not happy. So this is the right board. This is our proper board. So I think this one, U16, I think U16 might be our issue. Let's see. Can we figure out where? Hello, Aramis. Pin 13 of U25 should connect to crystal. Alright, we can do that. Where's pin U25? Or which one is U25? Okay, here's U25. Pin 13. Let's go over to U25. Pin 13. Sorry, give you the microscope. And oh, we have a couple of pins that are lodged together on that one. That can't be helping things. That's why you don't ship with your floppy drive just dangling about. Oh, that's not good. I don't like the way that looks. Let's see if that just does anything by itself. Let's just try it again. Okay, so that didn't change a whole lot, but still. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So yeah, we got nothing. Go there. That's dead. That was totally shorting. Just and it was pushed up against the next chip. Yeah, that's not, if that's, let's just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, that's not doing anything. Okay. Well, this has been a thing. So, yeah, just to show you. Go to here. Oh, you can't see what I was seeing. Nope. So that is the 14 megahertz oscillator. So where does that pin go? Does it go under that? Is our 7404? Helping to drive that clock? U26? Alright. Should we pop off that 7404? Oh, sorry, man. This is really bad. Bad YouTube. Alright, let's pop off that one and see what happens. Looks like that 7404 is somehow related, because this clock is, or this oscillator is good, but there's nothing going other places. U26. Well, my hot air station is warming up. Let's see if we can figure out where U26 is in the schematic. Oh, okay, here's U16. This is the thing that sort of, I think this is what helps change the speed of our processor. Okay, so that's good to know where that is on the schematic. But we want to know where U26 is. Or, yeah, U26. U24. U21. U21 has a crystal going into it. All right, well, we are warmed up. Let's go back to here. Pop that off for a second, and let's get rid of that 7404. And then we can look underneath of it and try to figure out where things are going. Moon in the new year. Hey, Rodville. Haven't made much progress so far. We know our crystals are good. Can't find those signals going into the big logic chips. Big fancy logic chips. Glue. Oh. 350 degrees here. So even though I use the Moo gun, I like to use hot air to help remove chips, just to be absolutely certain that we're not going to tear up traces. Okay, there we go. Just need a little bit. Just need a little bit. Ow, it's hot. Ow, that chip is hot. Alright, can we figure out where that goes now? Should we try to see what that chip, if it tests okay? Let's go back. Okay. Oops. $7404. That chip is good. Okay, well that's telling us a thing. Alright, let's look under there and see if we can see anything. What is happening under that chip? Where does the oscillator go? So this one goes to there. So if that one is really supposed to be a clock, it goes to there. And I think the way these are wired up in pairs if this is a hex inverter. I think those are sort of connected. No, maybe not. Let's poke at it with the oscilloscope, or the beat meter. So this pin goes to there, and it comes, it goes to there, okay, and then that goes to there. So that's going all the places. The other side of this one is not attached to those. Okay, let's check our resistance on this just to be sure. 330. 330. Okay. Well, that's good. So we should be able to see this on, which leg did I say it was? Oh, beat mode. Should see it there and there. Alright, so let's put that back in, put it on a socket. Here. Oh gosh, what just happened? Oh, the world is moving. Sorry. Oh god. Okay, this is good entertainment. Make sure to hit that like button, folks, if you like being entertained by a terrible YouTuber. Make sure to hit that like button. It was indeed like an earthquake. Alright, so I'm gonna take you. Gonna balance you precariously. This is I always forget about hitting the like button too on my own stuff. I'm not sure if I like my own stuff. Just gonna give that a little bit of solder on one of the pads. Make sure we're sitting down nice. Do another one. Okay. This is 100% safe. I think that's another sticker for you. Socket winch. No royalties needed. 100% safe. Oh. I'm gonna just drop off the big bed bench. Okay, just that. It's fine. Alrighty, let's try. Let's see what happens now. Let's see what happens. We should be able to pick up that 14 megahertz signal off of something on that. Let's do this just in case magic happens and it decides to go. Ah, God. Oh, God. Oh, God. No, we don't want you on. Why are you beeping at me like that? Okay. Let's go back. Add our ground back on this guy. And let's go to oscilloscope. I said go to oscilloscope. There we are. So that's doing something. Yay, there's our 14 megahertz signal going into that one, and I think it should also be right there. Yep. Oh, and you can't see what I'm doing. Oh gosh, too many things to precariously situate. There we go. Get you zoomed in a little bit. All right, so there we go. This one is there. It's there. It's there. Oh, and you still can't see. Basically all of these pins, not that one, have our 14 megahertz clock coming out of it. That one's high. I think that's the 5 volt. That one does not. That one does not. This one does. That one does. That one. That one. That one. That one. That one. Not that one. So all of the ones on this side have the 14 megahertz clock on it. So that's something. Yeah, I should be a better YouTuber, but we all know that's not going to happen. All right, so that's something. It's interesting which pin did that. Yeah, see, that one is what should be going to that chip, and those two are not going. So that's interesting. All right, so like I said before, I'm going to have to sit down and read more about the clock generation circuit on this guy, but at least we have something that we know might be screwed up. So we're going to call this here today. We'll be back at it on Saturday at noon, most likely still futzing with this guy. So yeah, this will be fun. Make sure to hit the like button if you wouldn't mind, or hit the dislike button, whatever. This thing I gotta clean up. I'm gonna try to clean up some of these traces between now and then that are a little scarfy, but I think some of them are sort of superfluous. We really got to focus on the logic chips, the fuse, and the special chips, and making sure we got clocks going to those, because it seems like the clocks go into those and then they go out to the processor, from what I can tell so far. Trina is streaming at 5 o'clock, so make sure to check that out. And want to thank my patrons. So, Mike Janka Crew, Matt Hargett, Gutbomb, Garth Beagle, Brian Gerford, David Starbuck, Ian Scott, Jamie's Hack Shack, All Things DG, Chris Angelos, Tech Ambrosia, Scout, Jack68K, Bacchus, Asmodeus, Devil Luke, Alan Gracia, Rudy's Retro Intel, Dustin Cooper, and Suika Pan, and my jank team, Hardware Hacker, Mark Kruger, III DIY, Charles Bullock, Dave's Vintage Apple Tech, Mark from Millennium Max, and Mr. Tech Gadget. I want to thank you all for joining me here today. I want to wish you all a Happy New Year. I hope everyone has a wonderful, healthy, safe 2026. It has to be better than last year. I shouldn't have said that out loud, but I really freaking hope it is. So I'm wishing you all the best. As we always say here at the Big Bad Bench, if you're a Trumper, go F yourself. See you all on Saturday. Bye, y'all. Okay, there we go.